For part two of this, we'll start with number 10 here, and you're asked to solve this using duplation and mediation, which are the multiplication technique that we learned about. And so the way this is typically done is that you're just going to write the two numbers. You can put a line between them if you wish or not. And basically, the bigger number you're going to cut in half. So we're going to do halves on this one. And we're going to double the smaller one. And we do this, if we take half and we end up with a remainder, we just round down. And we keep doing this until the left-hand column becomes 1. So half of 132 would be 66. Whereas if I double this one, it's 86. Half of 66 is 33. Or if I double 186, I get 172. Half of 33 would be 16.5, so I just round that down to 16. Or if I double 172, I get 344. Half of 16 is 8. If I double 344, I get 688. Half of 8 is 4. Double 688, I get 1,376. Half of 4 is 2. Double 1,376, I get 2752. Half of 2 is 1. And doubling 57 or 2752 is 5504. And so now that I have these two lists set up, what I do now is I focus only on the ones where I have odd numbers in my half column. So I only would look at these two and these two. And I'm just going to add the two numbers, or the numbers on the right in the right hand column that fall into these categories. So 172 plus 5504 equals 5676, and that's what 132 times 46 equals. So it is a shortcut method in certain respects, especially if you have a situation where the number produces a lot of evens in the left-hand column. Another method of multiplication we learned about, lattice multiplication, Napier rods are basically the same thing. Essentially what you do with that, because I mean all Napier's rods are actually physical rods that you would set up, and it would make essentially your lattice multiplication setup. I mean, so it's just basically, the numbers already been computed for you. It's really all it is. It's kind of like a chart. So if I'm doing that work, what I would do with that is, just put my digits 3, 4, 1, and 6 and 7 here. I make some boxes. And I write these diagonals in these boxes. Kind of sloppy there. But the diagonals should kind of intersect at one point. So let me just color that in. And all I'm going to do at this point is this, for instance here, 1 times 6 is going to be 6. So I'm going to write that as 0, 6. 1 times 7 is 0, 7. 4 times 6 is 24. 4 times 7 is 28. 3 times 6 is 18. 3 times 7 is 21. And what I do is I have these diagonals that I'm going to be using. Each diagonal, as I move from right to left, actually, is going to represent a different part of place value. So this is my ones. So I'm going to have basically 7 as my unit. Here is my tens. So I'm going to have 8 plus 0 plus 6 is 14. 14 times 10. This would be my hundreds. So I have 1 plus 2 plus 4, which is 7 times 10 squared, or 100. This diagonal right here, 2, 8, and 2, it's going to be 12 times 10 cubed, or 1,000. And I have this last one here, which is going to be 1 times 10 to the 4th. So I'm going to have 10,000 plus 12 times 1,000, which would give me 12,000. 7 times 10 squared is going to be 700. Plus 14 times 10 is going to be 140. Plus 7, and I add these up. So I'm going to have 22,000. 700 plus 140 is 840 plus 7. So I'm going to have 22,847. And if you actually do this on multiply this out on a calculator, you get the exact same thing. So these are just simply shortcuts that you could take to do multiplication by hand. Obviously, the shortest of all shortcuts is use a calculator. But if you're asked to demonstrate one of these methods, you do have to show the work that goes along with it. Next, computation with different bases. Now, you should be able to do the addition, subtraction, multiplication, and division with one. With only one digit. If it gets to 2 digits, it gets kind of complicated and things of that nature. Now, I'm going to show how you do the computations here, leaving them in the current base. Whereas you're more than welcome to take both numbers, convert them to base 10, do whatever you need to do, add, subtract, multiply, or divide. Get an answer and then put that answer back into the correct base. That's perfectly allowable. Gets a little tricky with some division, doing it going back and forth, especially if there's remainders involved. But that certainly is a method you can use. But as you do this, I mean, you just want to kind of keep aware of what's going on with the problems and things like that. So, so base 9, I only have the digits 0. We've got to get some pens here. 0, 1, 2, 3, 4, 5, 6, 7, and 8. If I have anything that goes over 8, then I have to start, writing it differently. So like the number 9 is actually going to be written as 10 in base 9 math. If I do an addition like 1 plus 6 and I get 7, not a big deal because that's a number that's in here. 2 plus 6, 8. That works fine. When I get to 4 and 8 and I get 12 in base 10, well, 12 in base 10 would be 19 plus 3 left over. So that would mean it's going to be 13 base 9. And so at this point, I would write a 3. And I would carry the 1 over here. So 1 plus 7 plus 3 would give me 11. 11 base 10. Stands to reason you're going to have 1 times 9 plus 2, or just no, it's 1 less than this. It's going to be 12 base 9, so I'm going to have 12 here. And so that's going to be 12,000, it's going to be 12387 base 9. So when you do addition, you have to be aware of, the digits that you're allowed and when you have to carry one over. You have to do that too when you deal with subtraction, but you also have to make sure you're borrowing correctly and adding things together properly. And in this case here, I'm also dealing with a base over 10, so I have to be aware of certain digits that are represented with letters. So for instance, this one here, since it's base 14, A is going to be a single digit representing 10, B is going to be a single digit representing 11, C is going to be a single digit representing 12. And I'm going to put these other ones in here because they might show up along the way as I go through and do the work on this. So it's just D equal 13. That's the only other one I could possibly have as a digit. So, so when I start the subtraction, 3 minus 2 is 1. That works out great. So no big deal there. Now I have 1 minus 4, which I can't do. So B is 11. So I'm going to cancel that out. It's going to become an A, because that's what's next in line. It's going to be a 10. And I have to remember that essentially now I'm adding, you know, a unit that's base 14. So I'm adding 14 to this. So I'm going to have a total of 15 here. And I'm subtracting 4 from that, which gives me 11, which is B. It's a single digit. A minus A is 0. That's pretty straightforward. C is 12 minus 3 is 9. So I end up with 9, 0, B1, base 14. So it works pretty simply as long as you're making sure you're adding the right values in. Going on to the multiplication, that's where it gets a little trickier. And that's where more work should probably be done, because it's usually best to kind of do the work in base 10 and then convert it to base 7. So for instance, as I work this one out, and since I have a double-digit number up here, I'm going to need to make sure I have enough room to do both digits. So I do 4 times 5. 4 times 5 is 20 in base 10. So that's well over 7. So 7 would go into that twice with the remainder of 6. So this is 26 base 7. So I write the 6, carry the 2. Now I do 2 plus 5 times 5. 5 times 5 is 25 plus 2 is 27. 7 goes into 27 3 times with the remainder of 6. So that's going to be 36 base 7. So here I'm going to write the 6. I'm going to carry the 3. Now I have 3 plus 1 times 5. Well, that's going to be 8. 7 goes into 8 once with the remainder of 1, so 8 is 11 base 7. So write the 1, carry the 1, and I'm going to have 1 plus 2 times 5, which gives me 11, and 7 could go into 11 once with the remainder of 4, so I get 14 there. So that takes care of the multiplication of 5. I'm going to do the next part in a slightly different color. So now when I do the next part, again, I could leave this blank or just put a 0 here. It doesn't really matter. I'm going to now do the 3 times 4, which is 12. And that's larger than 7, so 7 goes into that once with the remainder of 5. So I'm going to start with a 15, write the 5, carry the 1. 1 plus 3 times 5, which is going to give me 16. 7 goes into 16 twice with the remainder of 2. So I'm going to write the 2, carry the 2. Yeah, 2 plus 1 times 3 is going to give me a 5, and that's below 7. And so 5 base 10 is going to be the same thing as 5 base 7. So a 5 would go here. And then I have 2 times 3, which is 6, and that's below 7 as well. So 6 base 10 and 6 base 7 are the same thing. Now I have to make sure I'm adding correctly, so I go back to my adding from before, and these are all base 7s again. So 6 plus 0 is 6. 6 plus 5 is 11, but 11, as we've shown before, is the same thing as 14 base 7, so I'm going to write the 4, carry the 1. 1 plus 1 plus 2 is 4, so nothing happens there. 4 plus 5 is 9, which is 12 in base 7. It's 1, 7, 2 remainder. So write the 2, carry the 1. 1 plus 1 plus 6 is 8, and we know that 8 from before was 11 base 7. And so I end up with 1, 1, 2, 4, 4, 6 base 7. And so I'll make it a little bit thicker. That's my final answer that would go in here. 1, 1, 2, 4, 4, 6. Now with division, it kind of like do a side work as well if you want to make it easier on yourself. And you're often just left with having to be aware of how to do it with a single digit. The main reason being is we start getting the double digits, it becomes even more complicated. So let's work this one through. I'm going to carry through the division over here again because this kind of implies there's going to be a single number, but basically there could be a remainder. The remainders sometimes cause their own share of difficulties. Now because this is base 12, again, I had to be aware of the fact that A represents 10, B represents 11. As single digits, because the values of 10 and 11 would be single digits in base 12 math. So, and then I would have to be aware of all the multiples of A in base 12. So I'm going to list them here right now. So this is the list of all basically the factors, or kind of like doing a multiplication table of A base 12. And so as I look at this, obviously A is too big to go into 5 alone. So I'll go look at, 51. 6 times A to the 12 is 50, so I can start with that and say 6 times A to the 12 is going to give me 50. Subtract, I get 1. Bring down the next one, B, base 12. Now as I look at this, you have to be aware that B represents an 11. So this is basically a 1 in this position and 11 in this position. So I say 1 in the 12's position, 11 in the units position. 18 base 12 would be smaller than that, so I could put a 2 here and say, okay, I have 18, and I would subtract that. B represents 11, so 11 minus 8 is 3. 1 minus 1, of course, is 0. I would then bring down the 6. This is still base 12. All these are base 12 along the way. So I look at 36, 34 could go into that. It's smaller than that, so I could say that's going to be 4 times A to the 12. That would give me 34 here. And if I subtract that, I get 2 base 12. So basically, this answer is 624 base 12 with the remainder of 2 base 12. So the remainders get a little bit problematic, and again, another way of doing this is kind of convert this, make 51b6 into base 10, and of course A sub base 12 is 10, and divide by 10, get an answer. It probably may have a remainder as well, and convert both of them back into base 12 again, and take care of any contingencies where you might have to combine something else together as a result. But that's another way of doing it as well. Getting into some geometry. Now, just because of the fact that the examples I gave you here, I don't show anything with parallel lines and things like that. But you have to be aware of the rules of parallel lines too, and the angles along with that. I'm just trying to give some examples so that you can get on the right, mindset to take care of some of the things you have to know. So make sure you know all the rules about like what angles would be congruent, what angles would be supplementary, under various conditions. So. And that's what this one's actually asking. There's no parallel lines involved, but I do have a lot of linear pairs. I have vertical angles, things of that nature. So we're ultimately looking for the value of x there. I know that this angle here is 35 degrees. Because it's a vertical angle and therefore congruent to this one. This angle over here, I get a different color. This angle right here is supplementary with 136. So this angle is going to be 43 degrees. Now, whatever this angle is over here is the same as x. And I do know from the rules that we reviewed that one of the rules is that the three angles of a triangle need to add up to 180 degrees. So, so I do know that x plus 43 plus 35, 43, that's not right. This should be 44, not 43. Oh, I got 43 from. That should equal 180. So x plus 79 should be 180, which means that x would be 101 degree. Now these don't ever assume that these figures are drawn to scale. They're not always guaranteed to be, so don't say, well, it looks like it's under 90, so it should be under 90, and it didn't work that way. So make sure you're using relevant rules rather than speculation on your part. The shaded area. So what you're seeing there is half of a circle. Well, half of a ring actually, and there's basically two half circles here. I have a 7-inch diameter, which means that this radius is 3.5 inches. And I have a 14-inch diameter, which means its radius is 7 inches. So the area of the shaded region is the area of the bigger semicircle minus the area of the smaller semicircle. And the area of a circle is pi r squared. So a semicircle, which is half a circle, which is what this is made up of, would be 1/2 pi r squared. So the area of the bigger semicircle would be 1/2 pi times 7 squared minus the area of the smaller semicircle would be 1/2 pi times 3.5 squared. Now at this point it comes down to mostly putting it into your calculator. You could do, I could do some things with this and say, okay, well, 1/2 pi could factor out of this. Leave me with 7 squared, which is 49, minus 3.5 squared, whichever way you want to look at it, it's the same thing as 49 over 4. You can simplify this as much as you want. In the end, it comes out to be about 57.6 0.73. We're dealing with inches as far as the units, so this is dealing with area, so it should be in square inches. For the next one, the same type of premise. I'm looking for the area of a shaded region. I can see that, it's like taking the area of the circle and I'm getting rid of the area of the rectangle. So what you're seeing here is I have a circle. The circle has a radius of 13 meters because I can see that it's this diameter. I also have a rectangle where I have the length being 24 meters and the width being 10 meters. And therefore the area of the shaded region, as I mentioned when we started this off, is going to be the area of the circle minus the area of the rectangle. So the area of a circle again is pi r squared. So I'm going to have pi times 13 squared. The area of the rectangle is length times width. So that's going to be 24 times 10. So I have 169 pi minus 240. Since pi is involved, you're not going to be able to get a nice rational number or a terminating decimal. So I'm going to approximate this by doing the calculation, and 169 pi minus 240 is approximately 290.93, and that's in square meters. On to the next question. We have some three-dimensional figures. You're asked to find the volume and the surface area. And those formulas are provided in the notes and such, and you should have some notes to use during this exam as well. So make sure that you do have the formulas for the volumes and surface areas of the common things that you were asked to find. The volume of a cone is given by the formula 1/3 pi r squared h, where r is the radius of the cone and h is the height. And those two things are labeled quite well. So I'm going to have 3 squared times 12, which gives me 36 pi cubic centimeters, which sometimes they'll ask you to leave it in terms of pi if you ever see that like on some of your My Math Lab questions. If you approximate that, it is about 113.10 cubic centimeters. As far as the surface area goes, the surface area is obtained by the formula pi r squared plus pi r square root of h squared plus r squared, where again r is the radius, h is the height. Just substituting, 3 squared is 9, pi times 3 times the square root of 12 squared, or 144, so right is 144. Plus r squared again, which would be 9. And 144 plus 9 does not come out to be a nice perfect square, so I'm going to have a lot of irrational numbers. I can't even simplify it in terms of pi, really. So I'm just going to approximate it at this point, and that would end up being about 144.85 square centimeters. For B, that's a prism. So the volume is, for any prism, it's the area of the base times the height. Now, the thing is, I have to be aware of, obviously, a triangle, I would have a base and height in that as well. So I have to make sure I know the difference between the height of a face versus the height of the prism. This and this are the two bases. The height should be running between them. So this is the height of the prism. Everyone thinks that it's always vertical. It doesn't have to be vertical. So, and now the area of the base, it's a right triangle, so this could be a base and height pair for the triangle. So 1/2 the base times the height, so 1/2 10 times 10 would be the area of the base times the height, which would be 21. And if I work that out, it comes out to be 1050. And since we're dealing with meters up here, this should be in cubic meters. As far as the surface area goes, basically it's the area of each base plus the area of each face. I mean, so if I see here, so I need to figure out what this length is right here. It's not given to us, but we can see it is part of a right triangle right here. And so if I use the Pythagorean theorem and say, okay, what I'll call this side s squared should equal 10 squared plus 10 squared, which of course is 200, which means s would equal the square root of 200, which if you simplify your radicals, that's the square root of 100 times the square root of 2, which is 10 square root 2. Or if it's like, your right triangle sides and things like that from other math courses. So when I do the area of this, I'm going to have 2 times the area of the base, which is the 1/2 times 10 times 10. That takes care of this one and this one. I have 2 faces that are 10 by 21. And I have 1 face that's 10 times the square root of 2 times 21. And I have to add those together. Now again, because I have a square root of 2 involved, it's going to be irrational, so I'm not going to be able to get a nice decimal or a whole number or anything like that. So I'm going to need to approximate this, and that comes out to be about 816.98, and we're dealing with square meters on this one. So make sure you know the formulas and such for that, and it makes it a heck of a lot easier. Now this doesn't work much different than the area problems, except now I'm dealing with volume. And basically for this instance here, the volume of the shaded region should equal the volume of the bigger box, minus the volume of the smaller one, which is in white. That's essentially it. And anytime you're dealing with a box or just a regular square-based prism, the volume is going to be, length times width times height. It's represented differently. Since it's a square-based prism, I could say it's, side squared times height, where again, this is the height of the prism. So the height of the prism isn't necessarily 12. Okay, like I could probably make it that way, but so um, so I look at the bigger one. It's 12 by 12 times 17, whereas the smaller prism, the one in white, is 6 by 6 by 17. So basically I have 17 times 144, factoring out of 17, minus 36, which ends up being, and all said and done, 1,136. And this would be in cubic feet. So, basically anytime you're looking for a shaded region, you just have to try to find the two shapes that, one is, a bigger region minus the shape of another region that causes you to have like a hole or some sort, and that's how you figure it out. It's always through a subtraction. Now we get into some probability things here. This one is asking for an expected profit, so we're dealing with expected value here. Now this one's a little bit more complicated because, they're telling you how much you're going to get paid. Well, that's not a profit. The profit is like how much you paid versus how much you get paid for the insurance versus how much you paid out. So I got to keep that in mind as we do this. For this instance, my profit is equal to amount received minus amount paid. Have a little trouble getting it written over there. So for instance, if he gets $550,000, so not him so much because he'll be dead. I had to take that 550,000 minus the 4,800 that he's already paid. So here, my X value, because I'm going to let X stand for the profit, and that's going to be 545 200. If he's paid that 950,000, that means X is going to be 945 200. Those are the two payouts. There's only one other option where he gets basically paid nothing because he lives. So the X value for that is going to be basically the amount received is nothing minus the amount paid. That's a negative 4,800. So those are the three possible outcomes. Either he's going to get a profit of 545 200 over his family, a profit of 945 200, or a profit of negative 4,800. Nice to get their probabilities straight. So basically to get, $545,000, if he dies of sudden illness or accidental injury, they said there was based on their calculations, a 4% chance. So this is 0.04. The probability of him dying while performing the duties of his profession is 0.6%, which comes out to be 0.006 written as a decimal. And therefore, the only other outcome, these all have to add up to 1. So for that to happen, this has to be 0.954. So that's my probability distribution. And of course, my expected value should be the sum of my x times p of x. So 545,000 times 0.04 plus 945,000 times 0.006 plus negative 4,800 times 0.954. And if you work that out, and you get about $22,900. And so since the expected profit is $22,900, even based on these probabilities, that's what the policy is worth. So that's how that's figured out. So it's just another expected value problem. Just make sure you pay attention to what's given to you and what you're looking for. Since this didn't give you profits, it was a little bit more problematic, but most of the time, if it's looking for profits, it'll give you profits and so forth and so on. The next one deals with some probabilities as well, but it does give you a table of some information. So let's look at that table. Try to put it up here. So basically what we have here is, the number of students being asked for this poll, and then them signifying what their favorite class is. And so this is what we have here. Now, this information in each one of these cells is nice to have and maybe very useful to us. But on the other hand, having some of the totals would be important to us as well, because without those totals, we would have some difficulty trying to figure out what it is that we're trying to end up computing here. So one of the first things you should do with a problem like this when you are given it is even if you don't know if you need it for sure or not, is to total up your rows and columns. So this row totals out to be 50. This one totals out to be 52. And these have meaning. That means there's 50 seniors, in this study. 52 of the students here are juniors, 50 sophomores, 49 freshmen, for a grand total of 201 students. Now, as far as, class preference, 46, which is the total of this column, prefer math, 38 prefer science, 49 prefer history, and 68 prefer English. So you have to pay attention to what they're asking here for the various probabilities. I have 201 students total. I have row totals and column totals that will let me know, certain categories, what class they're in or what their preference is. But the cells would be a combination, of what a particular class and a particular favorite class, or class level versus, course. So when I say, what is the probability of picking a sophomore if I'm picking one student at random? Well, the sophomores, I have 50 out of 201 students. And if I work that out, it's about 0.2488. What is the probability of picking someone whose favorite class is history? So I have 49 people whose favorite class is history out of 201. And if I carry through that division, I get approximately 0.2438. Shift it over a little bit, don't know why. Now they said, what is the probability of picking a freshman whose favorite class is science? So this is more specific. Freshmen whose favorite class is science, there's 9 of those in this out of 201 students. So that's going to be a 9 out of 201, which is 0.1837. What is the probability of picking a senior given that you're only picking members of the junior class? If you think about it, it doesn't make sense. If I go to the junior class and say, how many of you are seniors? Well, none are going to tell me that they're a senior, because they're not. They're juniors. So that was kind of a tricky question. But they could have said, what's the probability of picking a senior given that you're only picking, uh, say students who prefer math? Then I would say, well, that would be that specific, here's seniors, there's 12 of them that prefer math. That'd be a 12 for that. But I'm only picking from, from the students who prefer math. So that'd be 12 out of 46 in that instance, which, you would simplify it. As far as these next ones go, what is the probability of picking, so you're picking 3 students a minute, what's the probability of picking 3 sophomores that have science as their favorite course? So, yeah, different ways I could possibly do this. These are pretty straightforward because there's not at least ones and things like that in there. So, looking at the chart above, I have 14 sophomores. Oh, I'll take that back. I have 6 sophomores who prefer science. And so, the probability of 3 sophomores who prefer science would be 6 out of 201 times 5 out of 200 times 4 out of 199. Now again, I'm doing it this way because of the fact that we're assuming we're not replacing. I mean, if I'm picking 3 students, I'm assuming I have 3 individuals in front of me and not me pointing to the same student 3 times, because that'd be kind of silly. If I work this out, it comes out to be about 0.000015. So it's kind of a remote possibility. It's pretty small. What's the probability of picking 3 seniors given that you're only choosing people that have math as their favorite course? So now we're picking 3 students, but only from those who have math as their favorite course. So if I come back up here again, maybe zoom out a little bit. There we go. I'm only picking from these 46 students here that have math as their favorite course, 12 of which are seniors. So the probability of picking 3 seniors given that, we're only looking at students who prefer math, would be 12 out of 46 times 11 out of 45 times 10 out of 44. And that works out to be about 0.0145. Now you can use some combination formulas for this as well, but since the table's set up this way, it's kind of easier probably to go about doing this. So sometimes, whatever formula or method you choose to use was very dependent upon what, information you have in front of you. And that's going to be the end of this video for part 2. I'm going to conclude with a third video for part 3 of this so that you can finish checking your work.